Good morning, Year 6. I hope you're all safe and well. Today is the 22nd of June 2020 and we're moving on to a brand new unit entitled Ratio and Proportion. So I hope you all had an amazing weekend and you're ready for our new unit and another new week of learning. I'd like you to write down today's date and our learning intention, which is introducing the language of ratio. And there's a little picture there to give you an idea of what we're going to be discussing. So our aims for today's lessons are to understand what ratio is, to describe the relationship between two values, to make simple comparisons, and for some of you to describe sequences in multiple ways. So for today's lesson you will need your pencil, you'll need a paper, your thinking hat, and the worksheets that were emailed to you this morning. You will need a timer, but I can't tell you which timer you'll need because you're going to set yourself a personal challenge and see if you can beat the time that you set for yourself. So you will need a timer, one that you can set the time on, whichever time you please. So for today's lesson, I would like you to write down the grid shown on screen and then set yourself a time to beat. So if you think, I usually find this a bit tricky, you might give yourself 10 minutes. And if usually you find your timetable is quite easy, you might give yourself 5 minutes. Off you go. And on screen you'll see the answers. So you probably won't need to check all of those, but there might be a few that you just weren't sure of. So just check them on screen and make sure you got them correct. So what is ratio? Well, ratio is a way to show a relationship or to compare two numbers of the same kind. We use ratios to compare things of the same type. For example, we may use a ratio to compare the number of boys to the number of girls in the classroom. So we might say there are 10 boys and there are 20 girls, so that out of 30 children, we have a ratio of 10 to 20. So when do we use ratio? We've talked about where we might use it in the classroom, but it's also commonly used outside the classroom. It can be used in cooking as well and in business. So in cooking, you might say, for every 2 cups of water you use, you need to use 3 cups of flour. And there's our ratio, 3 cups to every 2 cups, meaning if you double the amount of water, you need to double the amount of flour. Ratio can also be used when we're thinking about student and teachers in classrooms. So in our school, we usually have, in some classes, we have 1 adult to say 30 children. In other classes, we have a ratio of 2 adults to 30 children, or 1 adult to every 15 children. We know that when we go on trips outside school, the ratio of adults to child is 1 to 6 or 1 to 8 in some cases. So the ratios, how much we have in relation from one thing to another. So let's look at that in a bit more detail. Today, as we know, our learning intention is to look at the language involved with ratio. So if you have a look here, how many bananas are there to each of the monkeys? How many bananas to monkeys? Well, for every 4 monkeys, there are 5 bananas. 4 monkeys to every 5 bananas. Have a go at saying that sentence. Brilliant. Now let's look at the ratio of the cookies to the ice cream. How would you complete the sentence shown at the bottom of the screen? For every cookies, there is ice cream. Brilliant. For every 3 cookies, there is 1 ice cream. That could be written like this, 3 to 1. The colon in the middle between the 2 numbers represents 2. So 3, 2, 1. Instead of writing the word 2, we just write our colon. Now I'd like you to pause the video and have a go at completing the sentence shown on screen. Also have a go at completing the table. Brilliant. So for every 4 stars, because we can see 4 stars on screen, there are 4 green circles, which we can also see. And there are 7 red circles. So we've managed to complete our sentence looking at the relationship between the stars, the green and the red circles. How would we write that? Well, we'd write 4 colon 4 colon 7. 4 stars to every green circle, 4 stars to every 4 green circles to every 7 red circles. So our ratio can contain more than 2 numbers in, as we've seen in the example that we just looked at. But we need to make sure that when we're looking at our ratio, we're writing our numbers in the right order. We have to understand why we write 3, for example, in the first example shown on screen, why we're writing that the ratio of red to blue is 3 to 1 as opposed to 1 to 3. Well, red is the first colour mentioned. Therefore, that needs to be the first number when we write our ratio. Blue is the second colour mentioned, so it's the second number when we write our ratio. So the ratio of red to blue is 3 to 1. If I said the ratio of blue to red, then I'd have to write is 1 to 3. So whichever order you say the colours in, or the items in, is the same order that you need to write the numbers in. The ratio of green to blue is 1 to 4. Again, you can see that because green was mentioned first, and there's only one green, one must come first, and blue was mentioned second, so therefore the number comes second, and so on and so forth. I'd like you to have a go at doing it with the last ratio shown on screen. What does the 1, 2 and 1, what would it represent? Excellent. So the first one represents the red, because it says the ratio of red to blue to green. So 1 represents the red, 2 the blue and 1 the green. So if this is completely new to you, then I'd like you to just pause. It's a good idea to just pause the video here and complete the first page of the worksheet that was emailed to you this morning. And just so you know exactly which worksheet I mean, it's the one shown on screen. So whether you've gone and completed the worksheet that I've just mentioned and you've returned to watch the rest of the video, or whether you've just continued watching and you'll complete the worksheet shown at the end, either way, we're going to move on to looking at the different types of ratios that exist. So if you have a look on screen, you'll see there are a number of tortoises and a number of seals. How would we represent that using ratio? Well, we'd write down that there are 5 tortoises to every 3 seals, and we write our colon in the middle to show 5 to 3. But what if we doubled the number of tortoises in an environment? Well, we'd also need to double the number of seals. Now we know we've got 10 tortoises, we know that we also have 6 seals. Whatever I do to one number, I must do to the other, because that's what's needed in that environment. Have a look at screen. Here we have a look on screen. Here we have 1, 2, 3, 4, 5, 6 lions, and we have 4 elephants. 6 lions and 4 elephants, or 4 elephants and 6 lions. So for every 4 elephants, there are 6 lions. How would this change for each ratio? Well, let's look at the second one together. If I've got 2 elephants, then I must have 3 lions. And we can see that here. The same picture that we had before with 4 elephants and 6 lions, I could just group them differently. As long as I still have the similar numbers in both groups, I could still group them so that there is none left over. I don't have any lions left over or any elephants left over, but the groups are equal. Both groups have the same number of elephants and the same number of lions. I could do the same with, if I have 12 lions, then how many elephants would I have? Well, I know that when I had 6 lions, I had to have 4 elephants. So now if I've got double that number of lions, then I'm going to need to also double the number of elephants. So now I've got 8 elephants. Likewise, if I have 12 elephants, that means, remember I started out initially with 4. So I've times that by 3 to now say I've got 12 elephants. So now I need to do the same with my 6 lions. I need to times that by 3 to have 18 lions. So the sentence for this would change with the different numbers as we change our ratios. But all of these ratios really mean the same thing. If you think about when we're doing fractions, we always think about how we have to, whatever we multiply the top by, we have to multiply the bottom by. Well, it's the same with ratio. If you have a look here, the same grid that we've just looked at, you can see that where we went from 4 elephants to 2 elephants, we divided by 2. So we had to make sure we did the same with our lions. We went from 6 lions, so we divided by 2 to get 3 lions. If I stick with looking at the 4, if I times that 4 elephants, those 4 elephants by 2, I get 8 elephants. And so I must do the same with the lions. 6 times 2, which gives me 12. And finally, if I do 4 times 3, I get 12. So then if I do the same with the other side of my ratio, 6 times 3, I get 18. So, a math club has 25 members, of which 11 are males and the rest are females. What is the ratio of males to females? Have a go, pause the video and see if you can answer this question. If you're finding it a bit tricky, I'm going to put something else on the screen to help you. See if this will help you to solve this problem. We know this is the bar model, but it can also help us to represent ratio problems. 25 is our total. There are 11 males. How many are females? And what is the ratio of males to females? Well, the ratio of males to females is 11 to 14. Because if we do 25 minus 11, we know there's only 14 females. 11 to 14. Sadly, we can't simplify that anymore because 11 is a prime number. So there's nothing else that we can divide by 11 other than 11. And 11 doesn't fit into 14. Now it's over to you. I want you to write a for every sentence for the number of boys and girls in our class or in your class. So you might say for every, if you've got 30 children in your class, what number of them are girls and what number of them are boys, or what number are boys and what number are girls. And write a sentence using for every, I'm going to write a for every sentence using the socks I just seen in my drawer. For every 2 blue socks I own, I have 3 black socks. For every 2 blue socks, there are 3 black socks. I could also say that as for every 4 blue socks, there are 6 black socks. I'd like you to have a go at writing your own sentence thinking about the boys and girls in our class. Or you might want to write a sentence about something you found in your home. So, you might want to look at some of the socks you have, like I did, or you might want to look at some tins of beans and spaghetti you might have in your cupboard, or hairbands, or candles, or cups and plates. Can you have a go at writing a sentence for every sentence using the items you can see in your home? See if you can divide them down. So that's if you, instead of saying I've got for every 4 cups I have, for every 4 cups there are 6 plates, you might change that and say for every 2 cups there are 3 plates. And finally, so to finish off our lesson today, I'd like you to pause the video here and have a go at completing the sentences shown on screen. Brilliant. I'll put the answers on screen. So for every blue flower, there are 2 pink flowers. So for every blue flower means I'm just talking about 1 blue flower. So there are 2 pink flowers. You can even circle the groups to see, yep, we have an equal number in both groups and it still works. For every 2 blue flowers, there are 4 pink flowers. Rearrange the same number of cubes as there are in the diagram to help you complete the sentences. So we can see, you might want to use something in your home to help you with this one as well. So you might want to use some coloured beads or some pasta of different shapes, whatever will help you. And for every 16 yellow cubes, there are 8 blue cubes. For every 8 yellow cubes, there are 4 blue cubes. And for every 1 blue cube, there are 2 yellow cubes. Okay, so that one's a bit trickier at the end because we switch them around. But as long as you make sure that when you switch them around to look back at the previous answers and then switch them back again. And for number 3, how many for every sentences can you write to describe the counters shown on screen? Finally, we're going to finish off today's learning with some true or false questions. Let's have a look at the questions shown on the right hand side of the screen. Deciding whether they're true or false, writing your answers down, and then I'll put the answers up on screen for you. So for every red cube, there are 8 blue cubes. That's false. For every red cube, there are 4 blue cubes. For every 4 blue cubes, there is 1 red cube. We know that's true. We can see that. We could circle. We'd make 2 groups out of those. They'd both have 4 blue cubes and 1 red cube. For every 3 red cubes, there would be 12 blue cubes. That is true. If we were to add in another group, we would have 12 blue cubes and we would have 3 red cubes. And for every 16 cubes, 4 would be red and 12 would be blue. Well, that's not true, because we can see here that out of one group, 1/5 of them are red. 1/5 is red and 4/5 are blue. In that equation, that would be 1/4 is red and 3/4 are blue. And for the last one, for every 20 cubes, 4 would be red and 16 would be blue. That is correct, because that goes with our looking at fifths and looking at it as a whole and dividing it into fractions. So what next? Some of you would have already completed the first sheet that I mentioned in the middle of the video. And some of you might want to go back and do that first, but otherwise I'd like you to complete the work that was sent to you from levels 2 or 3. And remember to email us your work. We'll be looking forward to receiving it and also seeing all your answers to the questions in this lesson. Have a fantastic Monday. Bye.